I'm going to go through key problems on the 7-5 in-class work. The first example is a cubic root of 8 over t. What I'm going to do is I'm going to break this up into the cubic root of 8 over the cubic root of t. The cubic root of 8 is 2. The cubic root of t stays there. Now, an important concept here is that when we're simplifying a cubic root, we want to multiply this by something that will give us t to the third. Our ultimate goal is to have t to the third under a cubic root. Now, what we would multiply this by is the cubic root of t squared, because we would multiply what was inside and add these exponents, the 1 and the 2, to get the 3, and we would keep the cubic root. So we multiply by the cubic root of t squared on the top and bottom, and we end up with 2 cubic root of t squared on the top. And since these cubic roots cancel out, we're left with 2 cubic root of t squared all over t. And that is our final solution. On problem 14, we want the square root to go away on the bottom of the fraction. We don't care if there's a square root on the top, but on the bottom we never want a square root. So what we're going to do is I'm going to multiply this by the square root of 3 on the top and bottom. On the top I end up with 7a times the cube root of 3, or the square root of 3 rather. And on the bottom, these square roots go away and we're left with a 3, so it's 2 times 3, which is 6. On 15, you want to multiply the outsides, keep it on the outside, so 4 times 5 is 20. Multiply the insides, keep it on the inside, so 2 times 10 is 20. From here, we want to break this down. We want to say 4 times 5, because 4 is 2 squared. So when this comes out, it comes out as a 2. Square root of 5 is still inside, and we simplify it down to 40 square roots of 5. On the next couple of problems, we can only combine things that have the same thing under the square root. So in this case, we want to simplify everything down and then combine our like terms. So I'm going to break 32 down into 16 times 2. So I end up pulling a 4 out and doing 4 times 5 is 20, and a square root of 2 is still on the inside. I'm not going to go through this process fully because this is something that we have talked about before and in class. The square root of 27 is 9 times 3, so it should be 3 square roots of 3. And then the final one, 75, should be 25 times 3. 25 square root is 5. 5 times 2 is 10 square roots of 3. We can add the two terms together that have a square root of 3. The square root of 2 will stay by itself because it's not considered a like term, so 3 plus 10 is 13, and we have a square root of 3. On 15, we're going to multiply by the conjugate. The conjugate in this case, get rid of this stuff, is square root of 5 minus square root of 2. What I do to the top, I must do to the bottom. The reason being is that this piece right here is essentially multiplying by 1, so we are not changing the value. When I multiply the top by it, I'm going to keep it in parentheses. The reason being is so that it's easier to simplify if needed. The bottom, when I FOIL this out, because I'm multiplying this entire piece, I will get 5 squared under a square root, which will just be 5. Multiplying by the conjugate causes our middle term to fall out. If you want to FOIL this out, you will see it happen. I am not going to show it. I'm going to show the square root of 2 times the negative square root of 2 gives us a minus 2. So our final answer is going to look like with a 3 on the bottom. Problem 16 is much like 14. We want to simplify it down and then combine our like terms. I'm not going to do this problem for you. On our next example, 17, remember that these are squares. We want to get rid of the square root on the bottom. So what we can do is we want to multiply by something that's going to make this 13 an even number, because we know if it's an even number, it will simplify down and there will be no square root. If I multiply this by the square root of b and I do it top and bottom, then I end up with the square root of b to the 14th, which can be simplified. On the top, I end up with the square root of 5a to the 5th, which we'll take care of here in a second, b. On the bottom, b to the 14th is just b to the 7th. Whenever I simplify the top, I'm going to have a 5 that stays in, a b that stays in, and also an a that stays in. The reason that this a stays in is because I took a to the 5th and I rewrote it as a to the 4th times a. This is the a that stays inside the square root. A to the 4th comes outside of the square root as a squared. And we are finished. Problem 18 is the last problem that we're going to look at. The best way to approach this is just like the previous example. Since it is a cubic, we want to make sure that whatever we end up with is a perfect cube on the bottom. So our ultimate goal is to get to this point so that 5 is cubed, y is cubed, so that these can both cancel out with the cubic root, and we'll end up with just a number on the bottom. Now the way that we get here, the part of the journey here, is we multiply it by the cube root of 5 squared times y squared, because this portion will get us to where we want to go. If we do that to the top, we must do it to the bottom. So on the top, we will end up with 5 squared, which is 25, times 6, which is 150. So this has been accounted for, this has been accounted for. We have x squared, y squared, and it's all under the cubic root. At this point, we're going to take this and we're going to move it down here. When we simplify it, the top will stay the same. The bottom, these two go away, we're left with a 5. These two go away, we're left with a y. And this is our final solution on this problem. On 19, you're going to FOIL, so you're going to distribute each term in the first set of parentheses multiplied by each term in the second set of parentheses. And you can finish this problem on your own.